Hello everyone, I'm Robin, and I was just sitting here taking the specific gravity reading, checking in on my experiments that I have right behind me, and I thought, I should probably film this. I should probably talk about specific gravity and how you measure it and what it means. So that's what I'm gonna do. Now, specific gravity is the relative density of liquids, and hydrometers are used to measure that. And hydrometers can be used for a number of things. They can be used to measure the creaminess or the purity of milk. This is called a lactometer. They can be used to measure the alcohol concentration of distilled spirits. This is called an alcoholometer. I'm not joking. Or it can be used to measure the amount of sugar in a liquid, and this is called a saccharometer. And that's what I have here. I actually do have an alcoholometer hydrometer that I use to measure the alcohol concentration of my distilled spirits, but we're not talking about that right now because we're still at the fermentation stage for these experiments. So hydrometers are calibrated based on a standard. In our case, this is distilled water at 60 degrees Fahrenheit. So on this hydrometer, 1.000 is where the calibration point for distilled water at 60 degrees Fahrenheit is. This is also equal to 0 brix, which is the unit of measure for the weight percentage of pure sucrose. It's also 0% potential alcohol. So the way hydrometers are used in brewing, whether it's beer, wine, mead, sake, whatever you're brewing, you're going to take a specific gravity reading before fermentation. This will tell you how much sugar you have in that wort or in that liquid. And then you'll take a reading when the fermentation is complete. And this difference will give you an idea of how much alcohol you've produced during fermentation, or the yeast have produced for you during fermentation. The density of pure water at 60 degrees Fahrenheit is 1 gram per milliliter. In comparison, the density of pure ethanol at 60 degrees Fahrenheit is 0.79 grams per milliliter. So ethanol is less dense than water. A sugar solution, on the other hand, is much more dense than water. So as fermentation goes on and the sugar is converted into ethanol, the density of the liquid will go down. And this is how that difference in specific gravity relates to alcohol percentage. Being that the hydrometer is calibrated for water, this weight right here will float higher in a liquid that is more dense than water. So the higher this floats, the more dense the liquid is, and in our case, the more sugar that is in that liquid. This is based on buoyancy, or based on Archimedes' principle, which essentially just says that the buoyant forces that are exerted on a body immersed in liquid is equal to the weight of the fluid that's displaced by the body. Yeah. Temperature is also something important to note because temperature will impact the density. So when you take a specific gravity reading, you are also taking a temperature reading to correct the specific gravity based on temperature, because again, this is calibrated at 60 degrees Fahrenheit. So if you stick your hydrometer in, say, an 80 degree Fahrenheit wort, and the specific gravity reading is 1.080, what that actually means is that the specific gravity is really at 1.082. So it's a little bit higher than what you're actually reading. The higher the temperature of the liquid is, the lower the density reading will be. So for much hotter liquids, that specific gravity correction is going to be greater. Now, in order to get from difference in specific gravity to percent of alcohol, right? If you only wrote down the specific gravity reading, not the percent of potential alcohol, then you might need to figure out how to calculate the amount of alcohol that's actually in your wine or beer. And the way you do that is by taking the difference of the original specific gravity and the final specific gravity and multiplying that by 131.25, and that will give you percent alcohol by volume. Okay, so let's measure the specific gravity reading of these garbage strawberries that have been fermenting. The fermentation has officially stopped. So no more activity in there. The starting specific gravity with temperature correction for this fermentation was 1.063, which is equal to a little over 8% potential alcohol. Okay, this might be challenging to read, but it is sitting at 1.003. So that means it has fermented out almost completely dry. We're almost at 1.000, which is considered completely dry, AKA no more sugar. Hey Google, what's 0.06 times 131.25?
0.06 times 131.25 is 7.875.
So that means this wine right here is at about 7.8% ABV. Using a hydrometer is very simple, and it's essential for if you're home brewing at home. If you are going to start home brewing or anything like that, I hope that this video was helpful. If it was, go ahead and give it a thumbs up. Leave me a comment below and make sure to subscribe to the channel. And if you would like to support the channel any further, I also have a Patreon. I'll leave a link in the description below. But before I go, I want to say a huge shout out to my Patreons. Thank you guys so much for helping to support the channel and for being a part of this neat community that we have going over on Patreon.